So, good morning, everyone. Today we are going to start with a new subject. The subject is Signals and System with course code EE307. Before going to the subject details, I will tell you can use either these three reference textbooks. All these three are named with the same title, Signals and System, and one is written by Simon Heikin, and another one is by Oppenheimer, and the third one is by Nagrath. These are the three reference textbooks provided in your syllabus. Also, you can use another textbook, Signals and System by Anand Kumar, which is also available in our library, which is also a symbol textbook, that is textbook by Anand Kumar. Now, before going to the module details, let's see what is signals and system, or what is the subject deals with. The subject deals with signals and the system which consists of these signals. And about signal means how we can process a signal, that is while transmitting a signal or while receiving a signal, how we can process the signal, or what are the parameters which we can identify from a signal. A signal means an information. For example, we are going to transmit an information in the form of signal, every information in the form of signal, and how we can modulate the signal, or how we can modulate the signal in such a way that we can transmit it in a perfect manner, that is without affecting noise or with high clarity, in such a way how we can transmit a signal, or while receiving a signal how we can collect the information from the received signal. Maybe the received signal consists of the data and noise. And from the received signal, how we can identify what are the parameters in that received signal, and what are the information content, or what is the noise, and if it consists of noise, how we can avoid this noise. All these things we can find from the signal waveform or the signal parameters. For that, we have to identify what are the parameters in that signal. Then we can go for the systems which will consist of this signal. System means how we can the system which will perform the modification in the given signal. All these things we will cover throughout the syllabus. And before going to the all these details, first we should know about the basics of signals. In module 1, we will deal with all these things, that is what is a signal, what are the classification of signal, and what are the operations which we can perform in that signal, and what is a system, and what are the operations in that system, what are the properties of that system. All these we can see in first module, and in further modules and in the later modules we can see detail about these signals. So first we have to discuss about what is signals. So what is a signal? As we all know, a signal is a thing that contains information, or we can say signal is a function of one or more independent variable. So it is a function of one or more independent variables. So a signal which contains information, and this thing can be represented as a function which is a function of it is, or a signal can be represented as a function of one or more independent variables, and this independent variable may be time or distance or position, etc. For example, if you are measuring temperature, it may be with respect to time. With respect to time, we are measuring the temperature of a patient. It is a signal or an information, or the information may be depends on the distance or the amplitude of a signal with respect to distance, or amplitude, or measuring something with respect to distance or position. So signal is a function which depends on some independent variable. That independent variable may be time, distance, position, etc. Now, if we can say voltage and current, these are the functions of time. Normally, we will measure voltage and current with respect to time. And while studying in another module, we can see that we can represent different signal in terms of frequency also. If we have a signal which is depends on time, we can convert it into a signal which depends on frequency, that is conversion from time domain to frequency domain. Anyway, as an example of a signal, voltage and current is a function of time. Or അപ്പോൾ നമ്മൾ എന്തൊക്കെയാണ് പറഞ്ഞത്? Signal is an entity that conveys some amount of information that we can transmit or receive. So signal എന്ന് പറയുന്നത് may be some amount of information, or signal is a function of two or more independent variables like time, distance, position, etc. Or we can say signal is a function which will represent a physical quantity or variable which contains information. നമ്മൾ ഈ പറഞ്ഞു തന്നെ തന്നെയാണ് പറയുന്നത്. സിഗ്നൽ എന്ന് പറയുന്ന ഒരു ഇൻഫർമേഷൻ ആണ് which is representing a physical quantity or variable. That physical quantity or variable consists of some amount of information. And as we said, the signal is a function which consists of or which depends on independent variable. If the function depends on only one independent variable, then we can say that so if the signal depends on single variable, then we can say that it is one dimensional. So it is one dimensional. For example, speech signal. Example is speech signal. Speech signal is a signal which varies with respect to time. Its amplitude varies with respect to time. So speech signal is a one-dimensional signal, that is it depends on only one independent variable, that is time. Then what is multidimensional or two-dimensional? If the function depends on two or more variables. If the function depends on two or more variables, then it is called multi-dimensional. Example is image. Because if we will represent an image, it depends on the x-axis, it depends on the y-axis and some other parameters. So we can say it is a multi-dimensional signal. But in case of a speech signal, normally we will represent it like this, that is it depends on only the time. But here in the image, a particular position or particular pixel depends on both x and y parameters. And there are so many examples for multi-dimensional signal. This is one example, that is image. These are about what is signal. So signal is an entity which consists of information, and we can represent it like a function which depends on some independent variable, and based on the number of independent variable we can say whether it is one-dimensional or multi-dimensional. So next topic is classification of signals. So based on different parameters or different conditions, the signals can be classified into different categories. The first one is the signal can be classified into continuous time and discrete time signal. Second one is even and odd signal, and periodic and non-periodic signal, deterministic and random signal, energy and power signal, analog and digital signal. First, we can see what is a continuous time signal and what is a discrete time signal. As the name suggests, it depends on how we will represent this function. As we know, signal is a function, or how we will represent this function with respect to time. Based on that, this classification is provided: continuous time and discrete time. And a continuous time signal is represented as x of t, where the function have value for every time. This is time t. For every time t, we can see a signal x of t. That is, at each and every point of this time parameter, the function is available, or x of t is available for every value of t. That is why it is known as continuous time. That is, the function is continuously available for this parameter t or time. Now, what is discrete time signal? That is, the function is available only at discrete intervals of times, which is represented as x of n. Please note this representation. One is x of t and other one is x of n. In some cases, we will say that it is a continuous time signal. Then we will represent it as x of t. And if it is said that it is a discrete time signal, write it as x of n. Now, from this function, we can see that for every value of n, x of n is not available, or the function is not available. It is available only at these points. For example, if it is minus 3, minus 1, minus 0.5, and it is 1, 2, 3, 4, etc. For n equal to minus 3, the function is available, and for n is equal to minus 1, this function is available. Between these two values, the function is not available, or its value is not available. Now, the example of a continuous time signal is cosine signal, sine signal, etc. Normally, we will write it as sine of omega t. That is, it is a function of time t. If it is a discrete time signal, we will represent it as x of n. So this is the first classification: continuous time and discrete time signal. Second classification is even and odd signal. Even and odd signal. Normally, we will represent a signal as x of t or x of n. Now, if x of if we will find x of minus t, and if it is equal to x of t, or if we will find x of minus n, and which is equal to x of n, then we can say that it is an even signal. So signal x of t is said to be, or x of n is said to be even signal. Then if we will find x of minus t or x of minus n, it should be equal to x of t or x of n. That is known as even signal. And let us see how an even signal is represented, or in this case, an even signal is said as mirror image. It is said as it is a mirror image. So let us draw an example of even signal. Here you can see, as we said, even signal is a mirror image with respect to this axis, with respect to this origin axis. Here you can see, if we will look from this reference, the signal is same for the right side and in the left side. Or let us check for the condition x of minus t. Here you can see x of 5. X of 5 is equal to 0. Then if we will find x of minus 5, here x of minus 5, that is at t equal to minus 5, its value is equal to 0. Or if we will find a value from this point, that will be same for this x of minus t, that is called mirror image. Or we can see another signal, a square signal x of t. Here also you can see for every positive value its corresponding negative t. The value positive and negative indicates the time t. For every positive value of time t, the x of t is same if we consider x of minus t. X of t, x of minus t same ആണ്. So we can say that it is a even signal. Let us see another example. A signal like this. Here you can see, with respect to this axis, this portion is a mirror image of this value of x for the value of minus t. Or if we will find any value x of t for positive t, that will be same as that of x of minus t. ഇവിടെ നിങ്ങൾക്ക് കാണാം, ഈ ടിയിൽ ഞാൻ ഏത് വാല്യൂവിൽ കണ്ടുപിടിച്ചാലും മൈനസ് ടിയിൽ എന്ത് കിട്ടും? ആ സെയിം വാല്യൂ തന്നെ കിട്ടും. ദാറ്റ് ഈസ് വൈ ഇറ്റ് ഈസ് സെഡ് ആസ് even signal. Here it is a cosine signal. Here you can see it is a cosine signal. So an example of even signal is cosine signal or cos waveform. Then what will be odd signal? Odd signal means if we will find x of minus t and which is equal to minus x of t, or if we will find x of minus n and which is equal to x of n minus x of n, we can say that it is odd signal. So that is, this is, we can say that it is anti-symmetric. This is anti-symmetric, but even signal is symmetric signal. That is, with respect to this axis, it is symmetric in the two portions, or we can say that it is mirror image. Here we cannot say it is mirror image, but it is anti-symmetric. That is, if we will find x of minus t, that will be equal to minus x of t. For example, if we will draw a signal like this, x of t is drawn here as like, sorry, let's see in another way. If the signal is like this, then this is x of t and this is t. Then when we will find minus x of t, its value will be, if its value will be like this, that is, the magnitude is same but its sign is negative here. So if this is x of positive t, then x of minus t will be negative. Then we can say that it is a odd signal. Or we can see another example of x of n. For n equal to 1, this is n equal to 1, its amplitude is minus 1. This is x of 1. That is x of 1 is equal to minus 1. Now let's see what is x of minus 1. This is minus 1. And if the amplitude is 1, that is equal to 1. That is x of minus n is equal to minus of x of n. That is 1. Then we can say that it is an odd signal. These two are examples of odd signals. So these are odd signal. Now let's see another example of sine wave. We know this is a sine wave. This is x of t and this is time t. Let us consider this x of t for positive value, and if we will find this is pi. Now if we will find x of minus pi, or if this is pi by 2, x of pi by 2 is 1. If we will find x of minus pi by 2, its value will be minus 1. That is x of pi by 2 is equal to 1 and x of minus pi by 2 is equal to minus 1. That is x of, if we will find x of minus t, this is minus of x of t. Then we can say that it is an odd signal. So as we said, an example of even signal is cosine signal and an example of odd signal is odd sine signal. This is a sine signal. This odd and even signals are important for the gate exam also. They will ask for whether it is odd signal or even signal, and next we have to study about how we can find the even and odd parts of a signal. That is also important for this objective type exams. So next we can calculate the even and odd components of a signal. Every signal consists of even and odd components. That is, a signal x of t can be written as a combination of x even of t plus x odd of t. That is, the signal x of t consists of even component and odd component. If the signal is an even signal, then odd component will be 0, and if a signal is odd signal, the even component will be 0. Now, in other ways, the signal may consist of a portion of even component and a portion of odd component. And now we have to find how we can calculate this even and odd component. So, so as we said, x of t can be written as the sum of even component and odd component. Now we can consider x of minus t, that is t can be replaced with minus t. Then x of minus t is equal to x even of minus t plus x odd of minus t. Now what is x even of minus t? X even of x suffix e indicates that it is an even component. In case of an even signal, x of minus t equal to x of t itself, that we already discussed. So it is equal to x even of t. And next is odd component, x odd of minus t. In case of odd component, x of minus t equal to minus x of t. This we already discussed. In case of even signal, x of minus t equal to x of t, and in case of an odd signal, x of minus t equal to minus x of t. Now then we can write x of minus t is equal to x even of t minus x odd of t. That is, this x even of minus t and x odd of minus t is replaced with these equations. That is, now we have two equations for x of t and x of minus t. From these two equations we can find x even of t and x odd of t. By adding 1 and 2 we will get x of t plus x of minus t is equal to x even of t plus x even of t, that is 2x even of t, and x odd of t plus minus x odd of t, that will cancel out. Then x even of t is equal to x of t plus x of minus t by 2. This equation is very important. Now we have to calculate x odd of t. For that, let us subtract equation 1 from equation 2. That is x of t minus x of minus t, which is equal to, so is equal to x even of t and x of even of t will cancel out, and x odd of t minus x odd of t, that is equal to 2x of t. From that we will get x odd of t is equal to x of t minus x of minus t divided by 2. These two equations are very important. X even of t equal to x of t plus x of minus t by 2, x odd of t equal to x of t minus x of minus t by 2. In for your university exam, either they will ask to find out the equations for even and odd components, or they will give a signal and ask to find out even and odd component of the signal. At that time these two equations you have to know, that is x of t plus x of minus t by 2 and x of t minus x of minus t by 2. Next we can see some problems based on these questions.